All right, class, let us discuss this week groundwork and core training. And I'm going to spend a little bit more time on some core concepts that will be very, very helpful when we get to the ground-based training components in the exercise videos for this course. So first and foremost, what joints and tissues actually make up the core? So if we look at these photos here, we've got some very aesthetic core, physique photos that a lot of folks look to achieve. And, when you look online, you look in, Instagram, social media, whatever, TikTok, everyone's, showing off their 6-pack, 8-pack for some of these folks. And when we look at this, we say, okay, yeah, rectus abdominis, those are the main muscles there. The 8-pack, the 6-pack musculature that we see there, that's the rectus abdominis. And that's often what people are super hyper focused on visually, right? And so we have to be kind of consider that that is just one of the multitude of muscles that actually make up the entire core region, which we'll unpack here as we continue on. So now what about these muscles? These are the obliques. The external obliques are visible on the side there. The internal obliques are not visible. And when we go in a little bit further, there's some deeper core musculature that we need to acknowledge as well. So here on the left-hand side, we see the psoas, or the hip flexor group, which is made up of the psoas minor, psoas major, and the iliacus. You can see they attach to the anterior or the front part of the femur at the bottom there. They actually go all the way inside the pelvis, so in through your abdominal wall, into the pelvis, and actually connect to your lumbar region. So L5 all the way up to L1 to almost to T12 for the personal training students in the class. And that creates all sorts of potential problems, especially when we do a lot of hip flexor training, so leg raises, etc., sit-ups with the feet hooked in. This musculature becomes extremely overly tight, potentially, when you combine that with the amount of sitting we do, because the muscle will be shortened because of the sitting process. Now, on the backside, we have what's called the quadratus laborum, and that's just one of the muscles in the back, but it's a really big one, and it's actually part of what we call the guide wire system that Dr. McGill will speak about in a little bit in some of the videos that you're going to watch after this one. And that actually attaches to the top of the pelvis, but also stabilizes in the frontal plane for the personal training students and just the side-to-side position for all the other folks in the class. That's really important musculature as well that needs to be trained. And then we've got a whole bunch of other musculature, some of which I've already mentioned. That quadratus laborum on the left-hand side, the second one from the bottom. You can actually train that quite effectively when you do when you do farmer's walks. So anytime you do walking with load, it's that foot over foot position because the hip has to stabilize laterally. The quadratus laborum does that. So carrying heavy weight when you're walking is a fantastic exercise for quadratus laborum strength. Now we've got all this other musculature, and we're not going to go through each and every one, but a lot of the erector spinae, the lumbar portion at the lower component of the multifidus, and all of the little intersegmental muscles that work on some of its posture control, predominantly throughout the day. But there's a tremendous amount of musculature that makes up the core structure. And we can go even further on the very superficial component of all of the musculature. We have this white connective tissue, which is fascia. And we're going to cover fascia in a later module, especially when we get into foam rolling. But we've got on the front side of the body, the anterior aponeurosis on the left-hand side there. It's all that white tissue. It's all connective tissue, and it actually is integrated with muscle. And then on the back side, we have what's called the thoracolumbar fascia, and that's also that fascial tissue. Very strong. It actually communicates to muscles before the muscles actually fire. So it's actually an integrated part of the sort of movement system. And in fact, what a lot of the research has revealed is that fascia is ubiquitous. That's a fancy term for simply meaning it's everywhere. It touches every single cell in the human body, and it actually communicates electrically signaling to the muscles before the muscles move. And we can actually train fascial slings. And when we get into foam rolling, we'll talk about all of the slings that if you don't dissect muscle and you keep the fascial connections intact, we actually have these really long slings. That's for another day, so just bear with me. But that's also important to know that it actually makes up all of our connective tissue and certainly passes through the core quite robustly, because you can see all of that white connective tissue in these photos. So what does it all mean? So hopefully you can hear me. I don't know how this is going to work because I actually inserted videos into my PowerPoint. On the upper photo, we've got Mike Trout in slow motion swinging a baseball bat. And what you see is there's tons of musculature that I hope I've demonstrated that pass through the core. The core really is the trunk region of the body, the front and back, and all the tissues and muscles that cross it, including that connective tissue, fascia, ligaments, tendons. And then energy transfers through a stiff core, most effectively from the ground, and is expressed in the upper appendages. So you see Mike Trout swinging. Hopefully you can see that. Maybe rewind it and watch. Notice how his core stays parallel. His hips and his trunk don't move. There's no rotation there. It's his hips open as he drives that leg, and then he rotates and smashes the ball. Same with Cristiano Ronaldo. He actually, when he kicks, notice how still his upper body is. That all of the movement is coming through that hip. He's in single leg stance, striking the ball, and you can see that strike. He's got no movement in his upper body. His upper body in both of these athletes are super stiff. So core stabilization is essential for high performance and also a healthy back, which we'll get to here in a moment. All right, so yes, that is a picture of me on the left. There I am at Venice Beach with, sadly, my ex-wife now, but not sadly. Everything works out for a reason. With a gentleman in a Gowanna t-shirt named Dr. Stuart McGill, who is the spine doc. Now, on the left-hand side, this is really I just want to kind of introduce many of you, to the very first time you're going to be learning about spine health as it relates to core training. And what Dr. McGill has discovered is that high amounts of spinal flexion, forward bending, so think sit-ups and crunches, using light resistance or modest compression, as he found in the research, has been shown to cause disc injury and disc herniation. This was an advertisement I used to use in one of our facilities, and it really got people asking questions. We used to put these on a lot of the sit-up machines, and it said, hey, ask one of our exercise specialists for a safer alternative to this machine. That's why this is there. But Dr. McGill spent his whole entire career. He was is a professor emeritus at this point at the University of Waterloo, as he's retired. But he still goes and lectures, and he still does workshops on all of the research he's done on spine health and spine strength and preventing low back injury. So let's unpack this a little further. Dr. McGill looked at some models, and you can see three photos here, really three kind of sections, and I want you to focus on the colors. I know there's a lot of pictures here. What he discovered in his research indicated was that essentially loaded flexion with rotation in particular, bending the spine with twisting repetitively, caused disc herniation, disc damage. So on the left-hand side in the red group, you see there's a woman just doing twists, basic twists, kind of rotating to the right, rotating to the left. Now, if you just twist the spine, there does not seem to be any herniation. It seems to be a safe movement. So you can see that actually below her there twisting is an actual picture of the spine that he used. He built a jig. He got spine segments, and he injected anatomically, the disc itself has a jelly-like center called the nucleus pulposa. So the nucleus is jelly-like. Then there's multiple rings that go all the way around until the outside of the disc. That's called the annulus. And there's multiple layers of that annulus. And we'll look at a picture in a minute of sort of those layers. But what happens when you do certain exercises, potentially you compress the discs between your vertebrae. So what happens? Look at the blue section. So we have a woman there doing sit-ups, and you can see how her spine is what we call spinal flexion. It's bent. That's for personal training students. That's obviously spinal flexion, hip flexion. And she is, you can see how she has a fully flexed spine, especially when she reaches the top of her knees. And what we discovered, or what he discovered, Dr. McGill discovered, was when you do high amounts of spinal flexion, you will develop posterolateral herniation. So look at that dye in that left-hand picture next to that woman doing the sit-up. The dye has exploded through the multiple layers of the annulus, so the rings and the disc, and you can see that the dye has almost gone completely all the way out to the end. That is essentially a disc herniation. Now, let's go to the purple section. Twisting and flexion, so forward bending of the spine and twisting. And you see that gentleman. He is in a decline sit-up position, decline sit-up bench, or a decline bench with his feet hooked in, so he's firing up those hip flexors. He's got a weight in his hands, and you can see how his spine is forward flexed as he lifts himself up towards the end range of motion, or the top of that exercise, and then he's rotating to his left. It looks like he's got either a weight or a kettlebell in his hands. You can see that he's forward flexing, and he's adding rotation. So think about what's happening now to the discs in the spinal column. On the right, in purple, you see the discs that were injected, and where is the dye? The dye is everywhere. The disc has been destroyed. So twisting and flexion equals herniation and radial delamination. It is the surefire way, best way to destroy a disc. Now, does this happen after one session? No. This is cumulative. And what Dr. McGill demonstrated in his research was accumulation of all of these types of movements will be the catalyst for disc injury, potentially, depending on a few other things. I'd like to joke really quick at the very bottom there, that gentleman's picture doing the spinal flexion. That's typically a Russian twist. Notice in the back it says Gold's Gym. This is a very common exercise that you'd see in a bodybuilding gym, but this is probably one of the most terrible exercises you could ever do to your spine. Now let's look a little further here. So here, on the upper left-hand side, you actually see a nice diagram of the annulus. So that's the disc above the bone there. That's a vertebrae. Remember, there'd be a vertebrae at the bottom of that disc and a vertebrae above that disc. We've taken out the vertebrae above so you can see really the dissected disc. In the center, that whiter area is going to be the nucleus pulposus, so it's jelly-like. And then you see the rings of the disc on the outside. These are collagen fibers, cartilaginous layers that make the disc very rugged and sturdy. And what happens when you continue to flex the spine or flex and rotate, you get cracks in those different, in one ring, in the next ring, in the next ring, because the bones of the vertebrae, when you go into spinal flexion or forward bending of the spine, they compress that tissue, that cartilage, that rigorous disc material on one side. And you start to push the nucleus, if it cracks, through the back side. Now, so that's that first bullet point. Layers of disc annulus that crack during repetitive flexion and flexion with rotation. Now, the next two photos, the nucleus, let's see, you see annulus fibrous, nucleus pulposus, so that's essentially the same picture. They've flipped it over now of that disc. Look at the shape, though, of the lighter blue area compared to the one on the left, or the one in the middle, and the one on the right. The lighter blue area on the left and the middle picture looks oval, right? It's what they call ovoid. The one on the right looks more like a lima bean, which they call limacon. So what we know is that ovoid-shaped discs are better at tolerating twisting cycles, much better than limacon-shaped discs. Overall spine thickness is also a factor. So the thicker someone's spine is, the more quickly they may herniate with bending cycles or delaminate with bending cycles. But they can tolerate compressive stress, whereas a slender spine can survive more bending cycles, so think sit-ups and all of that, crunches, but it is not nearly as resistant to compression. The easiest way to think about this is genetics, right? A linebacker's spine, because of the sheer size of the athlete, is going to be much different than a golfer's spine. A golfer's spine has to deal with a lot of rotation, whereas a linebacker spine is going to have to deal with a lot of compressive force as they tackle people. Now, another factor, disc hydration matters. As the more hydrated the nucleus is, the greater likelihood of herniation. Interestingly, we are most hydrated, our discs are most hydrated in the morning. So maybe you don't do a rigorous, spinal flexion drill or core training, or maybe you save that till later in the day. And maybe you don't lift your super heavy weight if you're going to max out first thing in the morning. You might want to wait till you have some hydration. That sort of over the course of a day, what happens is the discs start to shrink down a little bit. They basically become full of fluid because of restoration and sleep, and they can be more easily compressed and more easily less tolerant to damage, so to speak. So probably not a good idea to do your max effort squats first thing in the morning, right when you wake up. Now the final piece, Dr. McGill jokes about this all the time. Genetics matter, and he would say pick your parents and then train based on the design of your spine. So how many of you, raise your hand if you've got ovoid or limacon-shaped discs? How many of you know if you have a slender spine or a thicker spine? How many of you know if you have any trauma, right? Any trauma to your disc that you've already suffered, right? Maybe you already have some that hasn't presented. Remember, disc stuff is typically cumulative. It's not a single event unless you have a car injury or you get thrown or something really traumatic happens. It's usually cumulative in nature. So raise your hand if you know all of these things. I suspect no one does. And typically what happens is you don't know what kind of spine and what kind of discs you're dealing with until you create an injury, and then you start investigating. So it is really important to make sure that you're training or minimizing risk of injury. So let's talk a little bit further about how we can minimize risk of injury and still get effective ground-based core training exercises in our arsenal. Okay, one last thing I wanted to mention before we actually demonstrate or show some of the exercise options that are out there that we'll cover in the video portion of this lecture, or the exercise portion of this module. So the military for years has done speed sit-ups, all right? That's that spinal flexion, forward bending of the spine. Do as many sit-ups as you can. That's part of your PT test. You've got to do a certain amount in order to achieve, get into the service, make sure you meet whatever requirements you have from the physical readiness standpoint. It's a mandatory component for their annual fitness tests, and soldiers are going to train the test. So the thought is, well, if I have to test on sit-ups, what exercise am I going to do when I want to get better, right? Or when I want to prepare for that test? Sit-ups, crunches, sit-ups, right? Now, recognizing their unacceptable low back injury statistics, they put together a research study in 2009 and tested the substituting of sit-ups training with planks. So standard plank, and then this exercise called stir the pot. So on the left-hand side picture, you see a gentleman with his forearms on the stability ball. He's actually making small circles on the stability ball with his forearms. And we're going to look at this in the video portion as well. They performed, so the soldiers that actually did stir the pot and plank performed better in the sit-up tests, even though they did not train them, and they had less injury. They had healthier backs. Now, this is what's fantastic. In May of 2019, the Navy votes down the sit-up for the physical readiness test. They don't do speed sit-ups anymore because of the evidence, because of the research out there. Now, many of you may be wondering, why the heck did I do so many sit-ups and crunches and all of this stuff my whole life? And my coach and, the trainer said to do it. I don't know why, but the research has been around since 2000. So Dr. McGill's initial research started in 2000. And he's been subsequently looking at a lot of this stuff over the years, and we're finally seeing the military almost 19 years later change, and that's great because we don't want to injure our athletes or our soldiers. They've got to be ready to do their job, not with a back injury. That goes the same for you guys. That goes the same for your clients. So share this information. This module is really, really super critical, and there's going to be a lot of really cool stuff that you're going to be able to share with friends, family, clients, and others who might be have been stuck doing sit-ups their whole life. All right, so what should you do to train your core now that you're thinking, my goodness, I've been doing sit-ups and crunches forever. Oh, no one told me. Well, that's why I'm here. So let's go through this. So focus on stabilization first and foremost, not constantly sitting up. The core is designed to resist movement, resist going backwards, resist falling left or right. So for my personal training students, resisting extension, resisting lateral flexion. That is what the core is designed to do, and that the abs are designed to keep the core engaged to protect and prevent any spinal cord trauma. So you want your core to be able to turn on at the snap of a finger when you have to create stability to protect that spine. Now in sport that happens all the time because you're running around, you're doing stuff. But even in day-to-day activity, right, you want to be able to kind of reach across and grab something and not have your spine buckle, right? So core stability really is critical. Now many students ask, well, what is core stability? What does that feel like? So I'm going to tell you right now, pretend like you're about to fart. That's right. I didn't make this up. Dr. McGill was like, if you want to get the experience of actually feeling what core stabilization feels like, try and fart right now. Go, push, try and fart. Do you feel when you're doing it? Go ahead, try it. Try and fart. Try and relieve yourself. Push, push, push. That interabdominal pressure that builds up, that is core stabilization. And that is the best protection that you have to help develop and create a really high functioning athletic core, but also a really strong core to protect you from the variety of things that might happen from a movement standpoint and protect your spine. So his recommendation is really focusing on these, what they call the big three, which are side plank, glute bridge, bird dog exercise. And the reason for that is because a lot of sitting, glute bridge, glute stuff, which we've covered in the hip hinge pattern, is something that has to be programmed into your exercise programs. And it doesn't require a lot. You can do a lot of variations, which we've already covered. The side plank is a great exercise, and you'll be able to see that in a minute in the video portion. And then the bird dog exercise. All of these have what we call low shear force on the spine, meaning they have the least amount of compression and the least amount of kind of spinal forces, but the core is really, really lit up. So it's a really great bang for buck core stabilization exercises, including glute bridging, because the glutes are really, really critical to a healthy back. So then you have some other options: curl up, dead bug, plank, this RKC plank, and then stir the pot, which we'll unpack here in a little bit in our videos. So you see here one of the big three, the side plank progression. So you see in the very first photo there, where it says side bridge in yellow, the gentleman's actually shirtless, leaning up against the wall. That is a very basic side plank. You might not think that it's much, but for someone who's just brand new to training, who's super deconditioned, that might be the highest intensity that you need. Remember, too much is not good. You have to dose respond the core correctly. Much like all fitness, you have to dose respond it. Too much can overdo it, and certainly with someone who has a history of spine or low back issues, you don't want to exacerbate that. Now you'll notice in that same one underneath the yellow side bridge text, he's got a gentleman who's doing a bent knee side bridge. He's also got his hand across his shoulder, and he's actually pulling down on his shoulder. That creates more stability in the shoulder. So if someone complains of, this bothers my shoulder, putting your opposite hand on the opposite shoulder and pulling down, straight down, will help create some stability. So you can do the bent knee, or you can do the straight leg. We'll get in the straight leg in particular, but it's hard to notice here, but in the video you'll see this, that you need the top leg foot should be in front of the bottom leg foot. And the reason for that is if you see the plyo elbow, where he's actually moving his elbows at the bottom three pictures, his foot position is set up so that he can actually rotate over his toes and go into a plank and then go into another side plank. So for my personal training students in particular, you can actually command out to someone, side plank right, side plank left, plank, and you can just sort of mix and match that as a really advanced sort of cueing exercise once someone's developed capacity to maintain all of this side plank and plank positioning. Here's another big 3 exercise called the bird dog. So it's a hand and knee, what we call quadruped, but you notice gentleman's raising one hand up in picture A, one foot up. And the idea is to move through the shoulder and the hip. Nothing else moves. I don't want to see the hip rocking or the hip rotating. And then in photo B, he's actually making box patterns with his foot and hand. That creates more core engagement, and that would be a progression, and you'll see a video from Dr. McGill on that specifically. Other core exercises that you're going to see include the Palloff press, some half kneeling with lift and chop, although I didn't put that in there because it requires a little bit more stuff, but any kind of half kneeling chop patterns where you keep the core stable is good. Partner stability, ball perturbation, we've got a video on that. Japanese stick work is the picture here. You see the 2 gentlemen. They're actually pushing against each other. So they're both actually working to stabilize. It's sort of like they're working synergistically, sort of working together. One is pushing one way, one is pushing the other, and they sort of give ebb and flow there. And what happens is by pressing through their upper body, they're actually generating ground force through their feet and their hips, and they're compressing into each other. That creates a lot of core activation as well. And then finally, we'll cover some more core exercises, many of which you may have not heard of, including rolling patterns, crawling patterns with animal components to it, the ab wheel, Supermans. We'll do some, we won't do TRX Superman. I'll do that in our TRX section. I'll show you all about that. But we also have anti-rotation landmine training. Heavy farmer's carries, which we've already covered, remember, because the quadratus laborum, that's a lot of core activation in that particular area. Remember I said in that carry lecture that we get a lot of core engagement when we do farmer's carries. And then, of course, sled pushes and walks.